Yes, hello everybody. So I'm going to talk about a little customer project we are right now implementing. So what I'm going to talk about is not yet in production, but it is already lab tested. And it's about integrating multiple Zabbix servers in multi-tenant environment. So what is the background of this project? We are a small company, just under 20 employees, and now we entered this project at a really huge, globally operating logistics company. They have their own IT department with their own development. Even in IT, there are several hundred people, so we are not doing everything there, but just supporting them with certain services. So for our company, it's mostly the log monitoring. So we have an Elastic Stack there that we are maintaining and operating. We are now implementing application monitoring using Zabbix there. And we are also doing some third-level support for the application servers they are using. So this is a small and specific set of tasks and not everything that's going on there. And that results in some problems with our usual workflow, because usually we do the full platform operation, just everything that is there, sometimes from bare metal or the cloud down to the application service and the application itself, providing everything they need, including, of course, the monitoring, and we have centralized monitoring system, one Zabbix server, basically for all our customers, so that we have one dashboard, basically, for our ops team, where we have all problems in one place. And we also integrated the Zabbix monitoring with other tools we have, like a ticket system and stuff like that, so that we just can really work smoothly with it. So, the special customer project means we have only the selection of services, and we shall offer monitoring as a service using Zabbix for the other teams. For example, all the development systems we are not responsible for, but we shall be responsible for monitoring them and offer them the Zabbix monitoring so they can use it. And so they required also having their own Zabbix server at their environment, because obviously they have a really huge IT. They want everything in their hands and their responsibility so that we can support them, but if need be, they can also operate it without us. And this, of course, contradicts what we are usually doing and what we usually want, just to own the monitoring at our place. And when it's in their environment, we cannot integrate it in our usual ways as we would like to. So we need a solution for this. To give you a little overview how it looks for us so far, just a bit simplified, we have our hard infrastructure, I would say. At this 5.com, we have our Zabbix server that is integrated into our ticket system, that is notifying our service desk and our on-call operators when we are doing 24/7 support. And at each customer environment, I just put 2 here for the principle. We have more, but it looks basically the same for all of them. We have the systems for the customer, whatever it is, usually collection of databases, application servers, whatever they need to operate, for example, lottery or web shops or such things are our usual customers. So we have a customer Zabbix proxy in their environment that is sending all the data to the Zabbix server, and from our Zabbix server we get notifications if there are some kind of notifications that affect their application contents, for example. So if a sports betting provider has no live bets, they have a problem, but that is mostly a problem with the contents and not with the application. So they can also get alerts. That's what I meant here with customer operations. And obviously, we would have liked to expand it just the same way. Yeah, our new customer, let him operate his environment for himself, but do it the same. But this was rejected because they said, we want the Zabbix server in here, in our self-managed environment. So it should look like this. And that made us think about what can we do so that we can get the stuff that is really important for us in our Zabbix server, and therefore in our whole workflow that is integrated with it. So we thought of some kind of replication and basically just replaced the customer Zabbix proxy with a new Zabbix server for him. And I'm going to tell you a bit how this works, what we did there, or what we will do there. So we have clear data receiver, that is our Sys5 Zabbix server, and the data sender is the customer Zabbix server. And we have to take into account that really limited access rights are acceptable for them. Just read-only access and through the firewall and all that. So we cannot do everything. We just have to focus really on one access and one simple access. So we are going to replicate all the data and necessary configuration. This means we are only replicating limited set of hosts because we only need those hosts that we are really responsible for operating them. So for example, Elasticsearch hosts or Zabbix hosts themselves, or the few application servers where we are responsible for providing support. But we don't need data from all the other stuff that we monitor with the customer. Zabbix as monitoring as a service only for the teams in their house, where we don't really need to react to alerts and stuff like that. So only some hosts, and we are only replicating the item and trigger configuration there because we do no configuration, for example, on the receiver Zabbix server. We don't need the templates from our customer Zabbix server, just the items coming out of them. And yeah, because of how this project worked, it was decided we need some kind of replicator, and it has to run on our server just so that it can connect to our customer. And we decided to do a little Python scripting there. First, I am going to tell you a bit how we are connecting to our Zabbix server. Basically, I put this little graph here saying we have. Let's talk about 3 API accesses to the Zabbix server. We have the REST API, we have the Zabbix sender API, where we can use the Zabbix sender tool to send data there, and the proxy, of course, the Zabbix server is connecting to its own proxies. And yeah, our ticket system is using REST API to do some updates in Zabbix, for example, to attach comments there when the ticket that was created out of a Zabbix alert got a comment or stuff like that as an acknowledgement, so that also our customers who have access can see that something is happening, for example. And so our replicator is connecting to our customer Zabbix server, as I said, that can connect to Zabbix proxies attached to that. And we are using the REST API to replicate the configuration that we need, the items and the triggers. And we are using the Zabbix sender API for the actual data replication here. So this is done using a Python script, basically more or less a quick hack, if you like to call it that way. It's based on the PyZabbix module. And yeah, it just needs a quite simple configuration file. It just needs to know which are the 2 servers it has to connect to and which hosts of that shall it replicate. And yeah, so when it has this, we can automatically replicate all the hosts and all the configuration and all the data we need. So on the data source, we are only using the Zabbix REST API with a read-only API user, so very limited access rights, as I said, to get all the data, all the configuration out of it. And on the receiver, as you have just seen, both the REST API for configuration and the sender API for the data. Using this, we need to do some automated conversions. When we are taking all of the items from the customer server, they are, of course, all different types. Whatever you can do, active checks, passive checks, using user parameters, etc., etc. But on our replication target, all of these become trapper items, so we can put the data there with the Zabbix sender API. And also, we add per host another item and trigger just to make sure the replication works. And all the triggers that are replicated depend on this, so that we see, yeah, we get no data from this host, but this is caused by replication not working. And so this way, when it depends, we just see, okay, replication is not working, we don't get a bunch of no data alerts or stuff like that, when actually it is everything working fine there, but we just have a connection problem to the other Zabbix server. Yeah, so that is what is automatically added. And yeah, we did the script. It can just run as a cron job. we made sure that it cannot overrun itself when it is running, because when you take all the configuration, you need some time to get all the items, all the triggers from the source server and replicate it on the target server. And it can automatically detect which hosts replication have to be replicated, because we are using a local replica cache on the receiver to make it easy to see, okay, this item on the source server maps to this item on the target server. Using item IDs and stuff like that, you need to make some API calls to identify that using the item keys and stuff like that. It takes a bit of time when this replication is done, so this is cached. And of course, when you have a cache, you can see, okay, this host is not replicated yet. I need to replicate its configuration, and then I can take the data. And yeah, the script we did is available on GitHub, so feel free to have a look at it if you want to. And of course, this solution, as I said, it is a quick solution we did, because we said, yeah, it would be nice to have it. Can we do something like that? So there's not really a lot of time that went into this, but it was just, can we do this? Prove this concept? Yeah, it works. Okay, bring it in a shape that it's good for this project. So, of course, as I said, it's a cron job. It is not running as a continuous service that could be monitored as a service running or stuff like that. And it is only supporting items and triggers now. It is not supporting replication of applications or templates or stuff like that. It could be added easily if needed, just the same way we have done it so far. The principle, when you have once done it, is not so complicated. But as I said, this is for this customer project at the moment, and we just did what is needed there. And another limitation we have at the moment, we are not automatically detected when the configuration of a host has changed. So if an item was added there, we can at the moment not really detect it fully automatically. This is also caused by runtime considerations mostly, because checking what is going on there always needs time, more API calls, more load on the systems. So at the moment, it needs a forced replication. Probably we will do this maybe once a day or so that we can get all data that is needed. But as this is still an implementation, we are not quite sure how this will end. Yeah, so demonstration, I have some screenshots from our testing. As I said, the production system is at the moment in implementation. Due to some delays, we said, well, let's just wait for 4.4. That's now released, so we can do it the next days. And for the test setup, I actually used our company's Zabbix server as a source, which will be the receiver in the real project. And in Vagrant, I just set up a Zabbix server as a target and just collected a set of 12 hosts I decided to replicate for this demonstration. And I will show screenshots from the initial replication, how this looks, what is replicated there, and also a bit on the performance impact this has on the Zabbix servers. So, yeah, just a freshly set up Zabbix server, nothing really on it, just a default Zabbix server host there, which is always disabled. And then I started the replication script, let it run for some minutes, and you see here a bunch of hosts which all received all the items and all the triggers. Actually, we see for the last one just one trigger in the screenshot, so I made this shortly before it finished. And yeah, they're all enabled. Interface doesn't matter for them because it is all via Zabbix Trapper. And yeah, so we are replicating just the last hour of data for the beginning. This is configurable, but we decided to do this because this way, when we already have 1 hour of data for each item, when we have initial replication, we don't get overwhelmed with all the triggers that would fire up if data is missing or stuff like that. So we make sure we have data first and then replicate the triggers for the host. So everything works fine there. And yeah, that's just to prove that. And yeah, the actual performance testing I did very late in the evening, and this is the reason why. What you can see here is basically 1 week, and you see when people are working. This is CPU load in green from the Zabbix front-end server we have, and red is the database server we have. So you can see weekend, no real activity there. During the weekdays, when people are in the office, yeah, Zabbix dashboard open in the background on every browser or stuff like that. We have some load. You can see it's really low. But this makes sure you cannot really benchmark such a small impact this actually has when other people are working, because it's just enough someone wants to look at some data and your whole benchmark is screwed. Yeah. So this is how it looked on the target server, so the Vagrant virtual machine. When we started the replication, we have high load at the beginning because it really goes through all hosts, through the whole API, one after another, taking all the items, all the triggers. This takes some minutes, also getting the initial data replication. This is not that fast, but after some minutes, it settles to quite low and yeah, really acceptable low load, like you would expect from normally operating Zabbix server, running on a laptop or with one core for the VM. So this is really not much effort for that VM and really low impact. And it looks similarly on the source server. This spike here, no idea what it was me, maybe some on-call activity or something like that. But you can see on the database server mostly the initial data replication. We have a lot of read requests in the database there, but when it's running, it goes basically back to the same level it has before. So it is a very small impact this has with this amount of hosts on the source server. And so in conclusion, we can say when doing this initial replication, we have very high load on target and also significant load on the source server, which is also the reason why we don't do stuff like automated detection of changed configuration also, because that would basically create a similar load to this. But when this replication is ongoing, we have a very small host, very small load there, at least for the number of hosts that we are seeing in this project. As this load scales per host, basically, this is not really a solution for a large scale, we think. But for a project like this, where we have maybe 2 or 3 dozen of servers that we need to replicate and all others, maybe hundreds of hosts when all this is finished, we have no need to replicate them. So when this would be necessary, this solution would not really be the best one, we believe. But in the scale we have here, yeah, you see the same performance impact like 2 more users opening the Zabbix dashboard and forgetting they have opened it. So that's basically the load impact we have there. So we are so far satisfied with it, and we are going to put this into production in the next days or weeks, depending on how fast this project is going to implement it. And in conclusion, what do we win, the before and after? Before, of course, we have 2 different Zabbix dashboards because 2 different Zabbix servers. And what's important for us when this replication works, we can have all that we need in one central dashboard, one Zabbix server, which of course is then automatically fully integrated into our usual workflow, because that's the main reason we do this. And this also means, yeah, of course, when you have only one server you have to take care of, you only need to do stuff like the user notification setup on one place. So this is, for example, when we are on call, the guy who is on call receives alerts via SMS, stuff like that. But when he's not, yeah, there's no need to. If you had to maintain this on 2 servers, it would be, yeah, extra work. You would have to think about, yeah, doing automated this, but you have no access from one cloud environment to the other. as I said, firewalls in place, etc., etc. You have only very limited access between the environments. Only this Zabbix replication port is basically open. And yeah, before split data ownership, to call it that way, some data we need is in their server, some data we need is in our server for operation. And now everything is shared in both servers. They are happy, they have all the data. We are happy, we can look into it in our system without the need to access theirs. And especially if there should be some problem with their network access, for example, we can at least analyze the data that was replicated so far. Maybe this helps when they have really a huge outage or like stuff like that. It's especially important for us because having access there due to Citrix and stuff like that, if that doesn't work, you cannot really see what's going on there. If the replication still works, you can see it. You cannot actually do something about it, but hopefully you know what to do already when you get access back or stuff like that. And so these are also caveats of dealing with a project where there are many service providers in a very huge framework there. And also a small detail, when you have such a split system, you have stuff like, you're using an SMS provider, and you have access to that, you have an account there, but to use it from the other system, you would need to put your account login data, your API access into servers they own. So company limits who is responsible for what is going on there. This is always stuff in discussion. Now with replication, it works like always because it is all we need is in our Zabbix server. So it really makes this life easier to have this kind of replication in place then. So that was so far my talk. Thank you for your attention. For questions, I think we have now the coffee break, so just come to me. Thank you.